Last speaker this morning is Shah, and she's going to speak about double field theory and alpha prime correction.
Okay, thank you very much. Am I audible? All right. Okay. Thank you very much to all the organizers for giving me an opportunity to talk a little bit about my work. So today I'll be talking about double field theory and alpha prime corrections, a case study. So as we'll go through the talk, it will show up that we are focusing on a particular case, or rather how one particular case pops up. Not my latest work with OLED, but I just thought it would be interesting to talk about this here. So, okay. So to start with a little bit of a brief motivation, thanks to Linus and Park, we had a good discussion over the workshop, which was going over double field theory and incorporating alpha prime corrections for the new audience. Double field theory, it makes T-duality covariance manifest, and it has been so far extensively studied at the leading order. But if you want to look at alpha prime corrections on its own, that's how one can genuinely capture all the stringy effects if one wants to go beyond the supergravity level. They happen to be quite important if you're looking at certain black hole entropy corrections, calculations. So far, the conventional methods that exist of calculating alpha prime corrections, like say by using scattering amplitudes or supersymmetry, for example, things do get technically heavy and a little difficult to organize. So an idea that came up some time ago, which was looking at alpha prime corrections through the lens of double field theory. The idea is that by using the manifest T-duality, it provides a more systematic and duality-friendly approach to look at all the alpha prime corrections as compared to the conventional methods that we have. So that's the motivation. Now, to go over the outline a little bit, as I just mentioned, from the motivation a little bit more, if you see that, is this the pointer? Yes, if you see the little red asterisk showing up there, that is to mention that I'll be sticking to, or rather my talk, 99.9% of my talk will be sticking to the area or to the regime where DFT and alpha prime corrections are still doing okay with each other. We are not touching upon the tension territory, the higher orders. So, but yes, there's going to be a little comment.
Are you working at leading order and string coupling?
Yes. No, we are not going like just nothing to do with GS, just alpha prime. All right, so that's a little comment. Okay, so we just looked at the motivation as to why it would be nice to look at alpha prime corrections through the lens of DFT. I'll talk a little bit about what double field theory is, what it does at the leading order, and then how we move on to the higher order corrections, say alpha prime order, and also I'll talk a little bit about the next order alpha prime square as well. We happen to consider a lot of examples where we try to construct alpha prime corrections in this particular prescription. And we'll see for what examples there happen to be no corrections whatsoever. And for some examples, there happen to be some. And then I'll conclude with some summary and some outlook ideas that we have. So DFT and alpha prime corrections, let's look into it. All right, so at the leading order, this is the DFT action that we have here. As you can see, everything is double. The phi and the h that we have here, those are the generalized DFT metric and the generalized dilaton that we have in the DFT. This action makes the duality manifest even at this level as well. Everything is OTT covariant. Now, in order to go back to the good old supergravity that we know, you impose something called as the section condition, and then that takes you back to the supergravity level, where this is something that we are very familiar with. So now let's look into some alpha prime corrections. Once again, going back to the DFT level, this first part is the curly R that we were just looking at, so that gives us the usual supergravity. Now we have these extra pieces showing up as well, which will take care of the alpha prime corrections. The little parameters A and B that you see in here are that's where the little alpha prime is sitting in there. So depending on what case you're working with, whether it's bosonic, heterotic, or type 2, these parameters A and B will have certain values, and that's how you can maneuver with the particular example you wish to work with. All right, so as I was talking about that, a particular case popping up somehow. So if you're trying to construct a new exact solution, the little tricky part is that what could be the starting point? That's a little difficult because these alpha prime corrections are sort of sensitive to redefinition. So you could be working it in one prescription and redefine it in one particular way, but the other person could be working in some different redefinitions where things could look a little different. So that's a little tricky part. Let's say once again, if you do something similar to what we did in the leading order, where you have the DFT action, you impose the section condition, you want to look at what happens at the supergravity level. If you do something similar and want to look at, instead of these curly R's showing up here, you want to look at the usual field content that we are used to. In the BDR scheme, it looks something like this, where once again, we have these A's and B's parameters coming in from there. The little H tildes also have these A's and B's parameters, so that takes care of the alpha prime correction part. All right, so now let's keep this action in mind, where once again, we have the usual torsion for Riemann curvature and the H tilde that I was just talking about. This is the usual H, the 3 form, and we have A's and B's once again sitting in there. So the takeaway from here, one thing to notice is the building blocks that you see in here, or rather for the building blocks for the alpha prime part, like this and these two, it's H tilde and this R plus minus, or the torsion for Riemann curvature. Or rather, if you really look with a magnifying glass, you'll see that it's just this torsion full spin connection, which is the building block, which is showing up here. So can we construct solutions with simple building blocks perhaps that are vanishing? As I mentioned, it's a little tricky to find new solutions because of the redefinition problem. What if we take it down even to this level and see if we can find solutions where it's easier to look at these building blocks themselves, and perhaps they could be vanishing as well. As someone mentioned earlier, if we are asking a question during the presentation, we probably do know the answer to that. So it turns out that yes, we do know the answer. To make things simpler, right now we focused only on the heterotic case. So for the particular case of heterotic, we only have one of these parameters contributing. So as I was mentioning earlier, that these A's and B's take certain values. So for the heterotic case, it's just A, which is contributing. So if you go back and take a look at the action, so it's just this part. You do not need to worry about the R pluses. It's just the R minus which is contributing, and similarly, you'll just have this first part contributing in the H tilde as well. All right, so what we try to do is we construct the class of solutions for which the twisted curvature is vanishing. So we try to dig up all the possible solutions for which this constraint is satisfied. So you start with assuming this constraint and then cook up all the possible solutions are, take the whole class of solutions. It actually turns out that the most physically interesting general solution for this case happens to be copies of S3, or rather product of near horizon geometries of various NS5 brane copies and just flat space additionally to it. So it looks something like this, the well-known CHS solution, but the near horizon copy. All right, so we also saw that it's not just R minus, but we also have this little H tilde sitting in there. So that's also one more piece that would contribute if you're looking at all the possible alpha prime corrections term. So it's not just this, but the H tilde actually it would differ only by redefinition. So it's more like a modification of the usual Bianchi identity that you could have. So you have the usual H, and then you could have the alpha prime corrected piece. So it's like a redefinition, but we'll come back to this later on. We can make this case even better. All right, so then let's move on to the next order as well. Yes.
May I ask a question? Because you are setting the Riemann tensor to 0, right?
R
I mean,
minus.
here it's the Riemann tensor, which also contains the H flux, right? So, but for the normal Riemann tensor, usually when you set the complete Riemann tensor to 0, you just can have the vacuum.
Yes.
Because even, when you don't have matter, so then you will set your Einstein tensor to 0, but you still have a Weyl tensor, which can be non-zero. So that means you can have propagating gravitational waves. But usually setting the Riemann tensor completely to 0 makes things trivial. How can I see that it does not happen here? So this is, I'm a little bit confused by
Yes,
that.
but it's not just R, it is R minus.
Yeah, because you have the H flux in there as well, right? So because the connection you use is the normal spin connection plus the H flux.
Yes, it's that.
And you are saying, so you can set it to 0 because there is some H flux, and so then setting it to 0 will not make it trivial in a way. So this is-
Yes.
Okay, thank you.
There's also something more, something related to this work, which was done back in 1920s even. There's something coming in from math. There's a theorem as well. We can talk about that as well.
Okay.
Yeah, which
So the thing
assures
is really
this.
the H flux, that you have the
Yes.
H flux, which makes it non-trivial compared to the normal geometry.
Yes.
Okay, thank you.
All right, yes, so we looked at the redefinition at order alpha prime. So if you have this, if you use this new H, you can rewrite everything in the same way that we know from the supergravity action itself, and things will be taken care of even at the order of alpha prime. So now moving on to the next order. This was, turns out that just by using some redefinitions, and especially for the case of heterotic, the action even at the level of alpha prime square can be rewritten in a very similar format as to what was seen in the previous order as well. This was done by Linus and group very recently. And so as you can see, once again, we have these R minuses showing up. We have this H showing up as well, but now this H looks a little bit different, where you have the usual piece coming in from first order as well, and then some additional pieces coming on from the next order. And once again, by following for the same solution that I was talking about, the most general interesting solution that we want, the near horizon NS5 case. Similarly, you can follow this redefinition, and now the H will look something like this. And you could just go on and write the usual supergravity action with this H, and it will take care of both the orders of alpha prime correction. Now, as I was saying, things will get a little bit better for alpha prime case. So let's wait for that. Special frames. So the idea is something similar to what Falk was mentioning, that let's say we compare things where things are trivial. What if we look at flat space? If we know that R vanishes, we know that there's a special set of frames where we can write even the spin connection actually happens to be 0 as well. Not because this is not unique. You can choose to write a certain set of frames where this is non-zero, but this would still vanish. So if you have taken this as your inspiration, what if we do something similar? Right now, our constraint is that R minus is 0. It actually turns out that we can find a unique set of frames where even this omega minus is 0, which means the torsion full spin connection is 0 as well. That makes things much easier. It actually turns out that we can obtain a unique set of frames, which is going to result in a vanishing spin connection with torsion. For the particular case that I have been talking about, the near horizon NS5 case, the set of frames look something like this. So yes, before I move on to that, if you feel like for the past couple of minutes, I haven't said anything to do with DFT, how is this relating to that picture? Let's combine the whole story. So we started with the constraint, which was looking at particular solutions or the whole class of solution, which will satisfy my constraint of R minus being 0. Now, by using the special set of frames, because omega minus is 0 itself now, this actually is giving us the curly R minus 0 as well. Now, this is how the DFT thing is tying up into the picture. So in these particular frames, if you're working with, you do not even need to take care of the redefinitions that I was mentioning at order alpha prime or even at order alpha prime square. Now, everything is just zero because we are working with these special set of frames. So we do not have any alpha prime corrections up to order 3, or rather 2, which way your convention is. How am I doing in terms of time?
Your point is what 10 minutes.
Oh, great. Thank you. So we not just that, but we also found some other examples, not found other examples, but rather looked at the alpha prime corrections of certain examples that are more or less known. But in this prescription, as I was saying, because of free definitions, things do get a little tricky. What exactly type of alpha prime corrections you see? So for the particular case of NS5 brains, I've been mentioning that if you have the near horizon case, you do not see any alpha prime corrections. But if you are going away from that, you do happen to get non-trivial alpha prime corrections. We also did take a look at the chiral-null model just to have a little toy model to work with and just making sure that even in this prescription, there are no alpha prime corrections as well. So we even looked at that. Moreover, we looked at the alpha prime corrections coming out of gravitational waves. So let's say you work with this, where let's say you are looking at all the possible combinations at higher order of alpha prime, which goes something as this. It turns out that equations of motion lead to 3 different dispersion relations, so and so forth, where this is the usual one, the standard gravitational waves. And these 2 branches actually do pop out solely because of having alpha prime corrections. That is something that we observe. And moreover, we also looked at the non-abelian T-dual of S3 case because S3 case has been popping. That's the case that we are looking at. So if let's say this is our starting point, you look at the non-abelian T-dual of it, but you want it to be alpha prime corrected. So that is something that we can do. And by performing the duality along the sphere directions, we do obtain the alpha prime corrected geometry, which is given as such. And yes, to give a little more detail, this was done along SU2. So to give some summary as to what I was talking about and some outlook ideas. So we looked at certain geometries that do not receive quantum corrections because of some term by term disappearance. So by looking at the building blocks themselves, the R minus or even R plus, for example, if we are looking at we go deeper into what exactly is contributing in these R minus or H tildes, it's the spin connection. So by looking at these term by term disappearances, in order to avoid the problem coming in because of the redefinitions, we can actually cook up the most general class of solutions that work with this case and up to alpha prime square order. It gives us some exact solution. So disappearance of twisted Riemann curvature implies that we can only have near horizon NS5 frame. That's the geometry that you can work with. Vanishing of R minus implies not just that, but by taking the inspiration of flat space, where if you have R being as 0, you can go to a set of frames where even the spin connection is going to vanish. So by taking that as an inspiration, what if we can have something similar for R minus as well? So it does turn out that we can go to a unique, nice set of frames, which are not the obvious ones, which would get these torsion full spin connection to be 0. And along with that special set of frames and R minus being 0, you go back to the DFT curly R minus being 0. So that's how the whole picture dies up. Not just that, but we also analyze several examples of solutions which have some non-trivial quantum corrections, as I just mentioned. Now, the 0.1% that I was mentioning, the rest of the whole talk is going to steer away from the tension area, but to give just a little idea or some outlook options or some nice open questions that could be interesting to look at, do come at order 3. Because it's a little, there could be some obstruction, there could be not. We don't really know how to tackle order 3 yet. So, but because of this particular solution, as I mentioned at the very beginning as well, that it's just a case study. It's one particular example, but it would be nice to get some insights out of it. So what could be the implications because of having this R minus zero itself? What more is it going to help us look at the or terms that show up at this order, or even having this new set of special frames, which actually can be extendable to other sorts of group manifolds as well? Is it anything better? Is it going to give us any nicer insights at next order? That is one question that one could think of. And moreover, what could be the effect of having R minus a zero? What could be the translation in terms of the generalized geometry part, generalized carton geometry part? What could be the translation in that area? That is also one question that one could think of. So those are certain ideas that we can think about, and I think that's it.
Thank you. Are there any questions? Yeah, you?
Thank you for the talk, first of all. Was there a reason which chose vanishing R minus instead of vanishing R plus?
Oh, okay, good point. So because we were only working with heterotic case, it's simpler because you only have one of the things to work with. That's why it went to R minus, but it actually does turn out that if you have the condition of R minus being zero, we can do some manipulations and even get to the constraint satisfying as R plus will be zero as well.
Okay.
Yeah.
Thanks for the lovely talk.
Thank
You mentioned, or you derived alpha prime corrections to various, to a few different geometries, right? So I was wondering if perhaps, you looked into these, what these look like from the double perspective, or in particular, I'm also thinking of these, results from about 10 years ago by Berman and Company, where they did, fundamental, say, string solutions and showed that they're equivalent to PP waves in double geometry. So I'm wondering, in this context, in general, like, what do these solutions look like from the double perspective?
That's a really good point. Unfortunately, we didn't really go to that double side. We didn't really look at that, but something closer was just to look at what happens with gravitational waves and having those two new branches show up. But yeah, like I do agree, that's an interesting point, but we didn't look into the double geometry, yes.
So I had a question about these gravitational waves. So what is the sign of k squared in these two new branches? It ends up being positive.
Yes, it
Should I
does
think
end
of
up,
these
yeah,
as
it does,
ends
it
up
does,
being
yeah,
sort of massive-
yes,
Massive gravitational waves. Is that how I should think of these? Or
yes, probably.
but the zero branch still survives.
Yeah,
It's not-
that's still, yeah, it's still
Okay.
there, the standard one, it's still there, yes.
There's some kind of factorization.
Yeah, there are these two branches that mainly show up solely because of that.
Anyone else? Okay, if not, thank you.
Thank you.